All right. So in these 20 minutes, I wanted to share you how we are using AI agents to maintain documentation. We have, as you can imagine, being a big company, we have a lot of documentation, and most of it is being manually maintained by our great content team, which is working with the product to figure out what's new for the product and how to best maintain it. But there's also saying that everything that can be automated will be automated. So this is probably true for a lot of documentation. There's one catch though. It has to be cheaper than human labor. Even though I don't really like the term human labor, it is sort of what it's called when you put your own hands on your keyboards and start typing. So in this talk, I want to share our strategy behind using agents to combine the work that our documentation team is doing with the work that our product team is doing with the work that our engineers are doing to save each other some time and basically automating the things that we don't like to do ourselves, because writing the docs is still a lot of fun, and it's definitely something a person should do and not AI, because otherwise all these documentation pages will start looking like each other. A little bit about me. So I'm Roy. I always like to speak at conferences or create new things for developers, whether that's videos or blogs or even books, even though I didn't write a long book for the past few years. Maybe I'll do so in the coming years somewhere. I work at IBM on some of our AI products in product management, but I'm also a lifelong developer, so I'm still writing code. Usually my code doesn't end up in production, but it is being used left and right in the company. So one thing that always annoys me about people building agents is they only talk about the agents. They don't talk so much about the components that give agents their power. So if you think about an agent consists of a lot of different things. There are roughly four components. So there's the agentic loop, which is the agent itself, from where tool calling is handled, from where the connection to the model is set up, from where the API is exposed that the user can use. And this agent always needs a model, of course. So this can be large language models, small language models. It can be a model running on your machine. It can be basically any model that you provide to the agent. Then it needs some set of memory. And quite often a memory an agent has is just a system prompt, or it's a history of previous messages. So quite often the memory is short-term only, whereas I think a lot of agents can benefit from having long-term memory. And finally, and this is the most important part in my mind, it's the tools. So these are the APIs or the databases or the files an agent has access to. And without any access to tools, the only real knowledge it has is its training data and the memory that you provide. So of course the tools are important because they help you to get the actual benefit of connecting to APIs, databases, and files. So a lot of people are building agents, and I see this every day, but not too many people talk about the tools. It's changing a little bit. Now we have MCP, or Model Context Protocol. More about that later. But up until a few months ago, people were talking about agents, what agentic framework to use, but they didn't talk so much about what tools those agents should use. So why is this? It always frustrated me because I worked a lot with APIs. So I like to build APIs that developers can use and then build products upon. And tools feel a little bit like APIs to me. And quite often, most tools are just a wrapper around an existing API. But in my mind, the agent is only as good as the tools it has. There's this quote from, I believe, the 60s saying that a man, or doesn't have to be a man, but someone doing the chores in your house is only as good as the tools they have. So if you have shitty tools, you're going to get mediocre results when you do some chores in your house. If you think about the agent, if the agent has shitty tools, it's probably going to do a mediocre result. It's maybe using too many tokens. It might have low accuracy. It might have hallucinations. So the tools are really important for the agent in order to give you the results that you need. So that's why I like more people to talk about the tools than just the agent. Also, if you think about it, large language models have advanced a lot already. So the application layer where you build your agent, where you build your integrations on top of the large language models, they deserve more attention. So I was giving another talk a few weeks ago, sort of highlighting how we went from the introduction of GitHub Copilot, which was already in 2021, to the launch of ChatGPT, which is 2023, to where we are today. If you think about it, the models have constantly changed. The application layer in which we use those models, it has changed a little bit, but still GitHub Copilot looks pretty much the same. There's an agent mode now, but all the other things are still the same. So the models keep advancing, but I do feel we sort of plateaued at a stage where the models are quite advanced already. We can probably make them more advanced, but we don't have the data to make them more advanced. So the application layer where you connect to the model, where you take your memory, where you take in tools, is probably a place where we can do more good and do more advancements. And people seem to agree with this. If you quite remember, at some point, everyone said every new startup is just a GPT wrapper. And that was true when we just had GPT available as a model. But if you look at it today, the wrapper around the model is way more exciting, and there's way more things you can do there. So the GPT wrapper, which people were making fun of before, might turn out to be the place where most of the value is being added. So I have a use case, as I mentioned in the beginning, where in IBM we have different sets of documentation being maintained by different people. So for example, being a big company, we have most of our products available as a software version, so as a SaaS version, and then we also have on-premise version. So this is when you buy a software license and you want to run the software in your own data center. And then we also have GitHub repos and NPM pages, PyPy pages, like pages where we make our APIs available, where we make our SDKs available, so it will be GitHub or PyPy. And then we have another set of documentation, which we call the Developer Hub. And for example, I'm working on our AI product called What's Next AI, where you can get access to models. We have documentation on-premise, we have documentation for software as a solution, as a service, and then we have APIs available for which the API references are in the docs for either on-prem or SaaS. But then we have GitHub repos and PyPy pages and NPM pages where we keep documentation for it's more reference, but where we have documentation for the SDKs that we have available either on NPM or PyPy to connect to the models, to build your agents, to work with tools, those kind of things. And all of these are maintained by different teams. So our documentation is maintained by the content team with help from the product team. Then the GitHub repos and the PyPy pages and NPM, they're maintained by the engineers working on the actual SDKs. And then we have this developer hub, which is maintained by the product team and some of our developer advocates. So you can think of the developer hub as a simplified documentation page with getting started tutorials, quick starts, these kind of things where we reference back to the official documentation, which has all the nitty-gritty details that you might be needing, but also back to the GitHub repos or the NPM or PyPy pages where developers can actually download the code they need. So all of this needs to be consolidated in a single place. And now mostly it was a manual exercise where if the content team updates the docs, I would need to go in there, find out what they changed, upload it in my developer hub, and then it should be good. Similar for the GitHub repos, I need to watch for changes. For the documentation, it's a bit harder because it's a CMS system, which doesn't have the most friendly APIs or version control. So in there, it became way more manual, whereas in GitHub, I can actually go and get a repo, look at the version control, and figure out what has changed or hasn't changed. So all these sources of docs need to be consolidated in a single place. And this is the single place. So this is the developer hub where you can find quick starts for using the APIs, for using the SDKs, a quick overview of capabilities, and it's all focused on getting a developer started as quickly as possible. It doesn't have all the nitty-gritty details that you might look for in product documentation. So my first iteration of building an agent for this, because I was kind of getting tired of doing this manually, and I also figured it would be a cool use case to get familiar with some new agentic frameworks. And this was some while ago already. I think I figured on LangGraph being my favorite React agent framework for the moment. For multi-agent, I guess I like other better. But LangGraph started out to be my first React agent framework that I actually liked. I'm mostly using TypeScript. So I was building a single React agent in LangGraph to get this done. I gave it a couple of tools, so a web scraper, a markdown to JSON, because the web scraper scraped markdown, and then a GitHub tool, actually two GitHub tools, either to create a PR, because the developer hub is maintained in GitHub Pages, and then another GitHub tool to read from a repo. So I wanted to read new files from the repo, for example, when someone changed our SDK documentation. So what I had this agent do is pretty much go to the on-premise docs, go to the SaaS docs, scrape the contents. And this first web scraper that I used a couple. Some of them got blocked by our DNS setup. So I finally found one that worked. A lot of companies like to block web scraping for good reasons. There should be some internal allow list though, but for good reasons they're blocking web scraping. So you need to scrape the contents, get it through my markdown to JSON tool, and then I needed to use these contents to create a PR to update some things on the developer hub. So basically the workflow you see here was condensed within an agent. So there was also a model involved that would take the results from the tools and turn it into the updated content. I also used a model to create a plan because I'm using a React setup. I have an LLM creating the actual execution plan for me. And this works kind of okay. It worked sometimes, it didn't work always. I would say overall, I had a pretty low accuracy. Sometimes it found changes, sometimes it did not. But most of all, the tools were hard to maintain. Because if you look at this setup, I'm creating all these tools by hand. So I'm taking in community tools from LangChain, for example, because LangGraph is built upon LangChain. But quite often I need to change these tools because my web page was doing something weird, or some results weren't as I expected, or tool definitions needed to be updated. And also my system prompt was getting quite lengthy, which isn't a bad thing per se. But the moment I changed something in my system prompt, basically anything would break. So I had a low accuracy, the tools were hard to maintain, and I also had a lot of errors. So this setup didn't really work for me. So I went to a second iteration where I actually start to explore some multi-agent frameworks. And multi-agent frameworks have good things. They also have bad things. So I like to not complain, but I like to compare. Multi-agent frameworks do microservices. If you do them well, it works pretty well for you. But if you don't do them well, you end up with quite a mess. And you probably would have been better off having a monolith. So the previous agentic setup we saw was a single agent, which is pretty much like a monolith. And this setup is going to be multi-agent, where I created domain-specific agents doing a specific thing, very much to how microservices are a collection of services that are doing something very domain or use case specific. So the tools were still the same, except instead of calling the different documentation sources from the same agent, I now build an agent for each of these sources. So if you look at the top, I have my on-premise docs, I have a web scraper tool, a markdown tool, and a GitHub tool in my first agent. Then I have a second agent for the software as a service documentation, which also has a web scraper tool and a markdown tool. And then I have my GitHub repos, which is a single agent, which has just a GitHub tool. And all of these are being orchestrated by a supervisor agent. And the supervisor agent has one tool, which is the GitHub tool. So only the supervisor agent is making pull requests to my developer hub. The other agents, they're just calling their tools to scrape contents from their source and then give it back to the supervisor agent, which is the only agent that has GitHub write access. So this worked at times. I sometimes had low accuracy because there has to be a handoff between these different agents. So maybe my on-premise agent will fail, or my SaaS agent will fail, or my GitHub agent will fail. If one of these processes failed, it kind of failed altogether. And this was getting kind of annoying, especially as the web scraper tool didn't always scrape the contents because of timeouts or it was being blocked. I also deal with a lot of tokens because the more agents I have, the more system prompts, the more tokens I'm consuming, the more expensive all of this is going to be. So this worked well as well. I'd say it's mostly a learning exercise because I didn't feel multi-agent was solving my problems. Because I did get even lower accuracy. When it worked, it was actually pretty cool. But multiple agents are hard to maintain, especially for such a small use case. Because I'm only having like 4 or 5 tools involved. So why would I need a multi-agent setup? Similarly to if I'm building a startup, do I really need microservices? Maybe I do because I have engineers that like to be prepared for potential scale. But if you have engineers that are worried about finding product market fit, you probably keep a monolith because you're able to move faster. So then, and I hinted at this beginning, I found out about Model Context Protocol, or MCP. So MCP is well, I'm inclined to say new, but in the world of AI, something being 6 months old, I might claim it's already being part of the long-running technologies. So MCP has been around for about 6-7 months. It was released in November last year, and it's a way to help people to consolidate how they would define their tools versus how the tools are being consumed by agents or clients or chat apps or whatever you might be building. So if you look at the right side, you can see you have several agents. The agents connect to MCP servers, and the MCP servers are pulling data from a database or some storage or an API. If you don't have MCP servers, you basically need to connect to each of these data sources from every agent, and you need to duplicate all of the code, because maybe I'm using LangGraph at one point, for which I need to use LangChain's tool calling format, but then I may be using OpenAI Swarm for my next agent, which has their own definition of tools, and then I might be using some other framework for my third agent. So each of these agents needs to individually create the logic to call these data sources. And this gets kind of annoying because there's a lot of duplicated code. There's a lot of code that could fail, code you need to maintain. So with MCP, you get a standard for how these tools are defined, and then you get a standard for how these tools are consumed. So any MCP client, being the agent in this case, or the chat application, is able to connect to any MCP server given they implement the protocol. So MCP really helps to separate the tool logic from the UI logic. And I figured this was most of my problem maintaining these docs, is that the tools were tightly coupled with the agent. So I'm saying UI logic here, but I'm mostly trying to say agentic logic, or wherever you implement the MCP client. Because if you look a bit more at the protocol, the idea is you have a host, and the host is your application. So it could be Cloud Desktop, it could be an agent you're building, it could be your own chat application. The host has a client in there that's using the protocol to connect to MCP servers. And you can have multiple servers, and each of these servers has a subset of tools. So each of the server doesn't have a single tool, it has a subset of tools. So an MCP server could be a GitHub MCP server, which has 20 tools to do each of the actions you can take using the GitHub SDKs or APIs. Something else might be a database MCP server, where you would have 2 tools, one to call the database schema and to have the LLM look at the database schema, and another one to execute a SQL query or whatever kind of database you might have. So there's a link to a blog post. I'm not sure if you can see it, but if you Google for it, you'll probably find it. I also have a video on building an MCP server and then using it in Cloud Desktop using TypeScript. So if you're interested in this, feel free to go to YouTube and search for my name. Just append MCP and you should be able to find something. So this brings me to my third iteration. So what problems does MCP solve? It mostly solves the problems I had on the tool side. So it doesn't help me improve my accuracy for the agent, but it helps me improve what I'm doing on the tool side. Because if you remember, my agent becomes an MCP client and my tools are the MCP servers. So my third iteration was actually the first one that worked for multiple reasons. So I kind of dropped the idea of using an agent in the beginning. So what I did, I took MCP servers to scrape a web page. I took an MCP server to convert Markdown to JSON, and actually found a web scraper that was able to output JSON. So I went actually from one tool to scrape and one tool to convert to a single tool that was able to scrape and convert at the same time. And then I would take the official GitHub MCP server to take contents from GitHub, but also to create PRs to update my code. And the nice thing about MCP is there's support for MCP in Cloud Desktop, for example. So the first time I didn't even have to build an agent because Cloud Desktop is an agent itself. So what I was able to do, I was able to take those MCP servers, take minimal tweaking, put them in Cloud Desktop, and actually ask to look for changes on the on-prem docs by scraping it, then converting it into JSON, and then creating a PR, all from Cloud Desktop. So this was a good way for me to check it out and see if it actually worked, how I wanted it to work. And then I was able to convert it into a LangGraph agent still. There is a library called MCP Adapter for LangGraph that allows you to take MCP servers and convert them into tools that are compliant with LangChain. So it was a pretty good setup for me. And in the end, I was able to optimize a lot of the work that I'd done. Unfortunately, I'm not able to share the code, but I was able to pull together these diagrams, so which hopefully helps you to get some understanding. So MCP, it was able to solve my issues because this client-server protocol interaction means I had way less code to maintain and code that could fail. And I also got access to now thousands of tools other people built. And the separation from the agentic framework allowed me to be more flexible because I was able to use Cloud Desktop and play around with my MCP tools there, rather than spinning up an agent and trying to figure out what might be going wrong. And also, which I personally really like as I am a developer, the MCP servers can be tested independently. So you can build your tools independent from the agentic framework, meaning you can also test them independently. There's a utility called MCP Inspector, which is a bit like Postman, but specifically for MCP, that allows you to test these MCP servers and play around with them independently. So authorization for MCP is still a bit fuzzy. There's support for OAuth. You, of course, can take client credentials or API keys when you deploy your MCP server somewhere, but authorization is still something that's being fixed. In IBM, I lead a big work group where we work on MCP and implementations for MCP across the product portfolio. And we're also looking to contribute back to the protocol. So hopefully we can do something around authorization there. So long story short, as we're all building these agents, whether it's to maintain your documentation or whether it's to do something else for work, or maybe in your personal life, maybe you like to scrape LinkedIn and look for leads because you have a startup, or you like to scrape LinkedIn and look for potential job offerings because you're looking for a job. You can automate a lot of this and it's going to make your life easier. It doesn't always mean it becomes better. But as you're building these agents, it's a lot of trial and error, and you're going to figure out the tools really are important when you're building these agents. So thank you. There's a link to a Discord channel where I'm active in case you have any questions. But it looks like we might have a few minutes now as well. So thank you.